Okay, in the second experiment with the sound wave, I have this resonance tube, and basically what we're going to do is we're going to change the length of the column of air in the tube to again set up standing waves. Okay, if you're to look at the end of this, the tube in here, there's like a solid barrier, so the wave is going to be generated by the speaker here at a certain frequency. So actually we're going to use 500 hertz, so 500 times a second. It's going to oscillate back and forth, or 650 hertz. It's going to propagate down, bounce off of that barrier, and come back. And if it's the correct length, then it'll set up these standing waves. So in this case, how do we determine whether we have a standing wave or not? We will hear a resonance. You'll hear an increase in sound. So what we're going to do in terms of data collection is I'm going to measure. There's a little tape measure here that gives the distance from the speaker to that barrier. So we're going to measure when the sound increases each time, and that is going to represent a node. So we're going to locate all the nodes. And then later, given all the information, you guys will be able to compute the speed of sound. Okay? So let's do this. I'm going to put this at 500 hertz. I'm going to turn it up a little bit. This lab is actually a little annoying at times. It gets really loud. So, all right, so there's 500 hertz. Let's see if we can locate the note. So you should hear the sound increase when I slowly pull this out. So it looks like around 8.5 centimeters, and we want meters, so it'll be 0.085 meters. Okay, so that's the location of the first node. In other words, that's when this distance is 8.5 centimeters. Okay, so let's find the next node. Somewhere around there. I'd say around 42.5. So 0.425. Again, I will post all this data later online. Now the third node, I should be able to find 4 nodes at this frequency. Looks like right around 77. Let's call it 77, so 0.77. And we should be able to find one more node. That one's kind of hard to hear, but it's around 111. We'll call it 111. So 1.11 meters. Okay, now I'm going to do the same thing, but I'm going to change the frequency. I'm going to increase this frequency to 650 hertz. And we'll locate all the nodes at 650 hertz. And we should actually find 5 nodes, which means you guys will be able to compute 4 node-to-node distances. In the other case, the previous case at 500 hertz, you will be able to compute 3 node-to-node distances. Okay, so here at the first node, it's a higher frequency, so they're going to be smaller wavelengths, so it'll be shorter. Right around 5.5. Okay, so 0.055 meters. Second node, I'd say 32, so 0.32. Third node, I'm getting around 58, so 0.58. Maybe 85, so 0.85. And then we should be able to find one more. I'd say around 112. So 1.12 meters. All right, great. So that's all the data for the resonance tube.